Okay, in this video, we want to solve a Bernoulli differential equation. So we have y prime plus x times y is equal to x times y squared. If you notice, we have a y squared here, so we can't do a simple differential equation, and so we'll do using Bernoulli equations. So right here, this is 2, right? So we can say that n is equal to 2, and with Bernoulli equation, there's a formula. It's v is equal to y raised to 1 minus n, where n is this number. And so for us, our v would be v is equal to y. So 1 minus 2 is negative 1. But we can also say that y is equal to v raised to negative 1, because if we multiply this by times negative 1, we'll also have to put 1 times negative 1 here. So we could say that y is equal to v raised to negative 1. Next step is we get y prime. So we say y prime is equal to, we differentiate this, so we would get negative v raised to negative 2 dv over dx. And so I'm going to start a couple of things. So for Bernoulli equations, this step is unique. This step is also unique. And we will use this, and this shortly. So let's get started. So what we're going to do here is replace, y prime with this, replace y with this, and that's it. So let's do it. So y prime is negative v raised to negative 2 dv dx plus x times y is v raised to negative 1 is equal to, we said y is v raised to negative 1, so we have squared. So that's going to be x times v raised to negative 2. I'm going to scroll down for a little bit more space. And the next step is we want to have this in standard linear form, so we will divide this all over. And so we're going to get dv dx plus, actually minus, it'll be negative, so we'll get negative x times v, because if we divide this by v raised to negative 2, we would get negative 1 plus 2, so this would be just v, is equal to, this would be negative x. So now we get a integrating factor, so we say that mu is equal to e raised to negative x dx. So this term right here. And so the integral of negative x dx would produce e raised to negative x squared divided by 2. The next step is to multiply this integrating factor by this standard linear form. So we'll do that now. So we would get e raised to negative x squared divided by 2 dv dx. So this times this, minus e raised to negative x squared divided by 2 times xv is equal to negative x times e raised to negative x squared divided by 2, like this. And so the next thing is we focus on this, and we do what we normally do. We say the integral of this, parentheses, it's going to be v times e raised to negative x squared divided by 2, and the prime is on the outside, is equal to the integral of this term right here, so negative x times e raised to negative x squared divided by 2. The one thing that is unique from when we do normal differential equation is this v multiplied. Normally, it would simply be this, the prime sign on the outside. But for Bernoulli equation, we need to put v times this. And so let's continue. So this would be v times e raised to negative x squared divided by 2 is equal to, the integral of this is a little bit more trickier. We can do u substitution. So if u is equal to negative x squared divided by 2, Then our du would be negative x, so this term would be canceled, and we would get e raised to negative x squared divided by 2 plus arbitrary constant c. And so the next step will be to divide this term all over. So we would get v is equal to this term divided by this would be 1 plus c divided by this would produce c e raised to x squared divided by 2. And if you notice from the very beginning, we defined v. So let me go back to what we originally had. Originally, we said that v is equal to y raised to negative 1. So we're going to plug that back in. So we will say that if v is equal to y raised to negative 1, we can essentially just flip everything. We can say that y is equal to 1 divided by 1 plus c e raised to x squared divided by 2. And this would be our final answer.